Okay, so today we're going to talk about dimensional analysis. I'm going to write this down real quick. So, this sounds a lot crazier than it is. Dimensional analysis, which is also called the unit factor method is a problem-solving method which uses the fact that multiplying a number by 1 does not change the value. So, I'm going to write that down. So, also called the unit factor method, is a problem solving method which uses the fact that multiplying a number by 1 does not change its value. Okay, so what exactly does that mean? So if I asked you what 1 divided by 1 is, and you multiply it by 1, it's 1. 2 divided by 2, multiply it by 1, it's 1. X divided by x, that is 1. No matter what, even if you multiply all these by 1, it's still going to be 1 or whatever that number is. Like, say I had 2 over 1 times 1. 2 divided by 1 is 2. You multiply it by 1, it's still 2. If I did chair divided by chair, that would be 1, because chair could mean a number in this instance. It's just a variable. And then etc. You could do this example ad nauseum and come up with your own little variations. Anyways, I'm gonna make a quick note here. So, chemistry is explained with lots of math, but it is not a math class. Just if you kind of treat it like a math class, you're not really going to understand what's going on. You might be able to solve problems, but it might not make sense. So you do need to know math to understand chemistry, though. All right. So when we use dimensional analysis, kind of going back to when I was talking about conversion factors in the lesson about standard units and all that, we use known conversion factors to change between units. I'm going to give you a quick example. So you could write a conversion factor for inches and centimeters in one of two ways. The reason I chose this is exactly, it's not like an approximation, like there's exactly 2.54 centimeters in 1 inch. So you could write this depending on what you're converting between either of these two ways and it'd be correct. So if I told you to convert 20.32 inches to centimeters, which one would you choose? So think about it for a second. And then if you look at this, I'm going to write down the problem and then I'm going to explain it. So we have convert 20.32 inches to cm. All right. And I want that in 3 sig figs. Okay. So if you write down what you had starting over here, I like to explain it like this. I always write down from the problem what I have. And then on the numerator side, the unit that you're looking for. Oh wait, I wrote that backwards. Wow. It's inches, not centimeters. I write what I have, and what I'm looking for goes in the numerator. And on the bottom is the other unit for the conversion factor. So the reason I do it this way is because usually what you had goes on the bottom. Well, not usually, it goes on the bottom. And then we write our numbers in. So this 1 inch, 2.54 centimeters. So we're going to multiply this in the calculator. We have 20.32 times 2.54. You don't really have to type in the divided by 1, I'm just showing you. So if I wanted 3 significant figures, 51.61. That 1 is what drops, so your answer is 51.6 centimeters. And as you can see, dimensional analysis isn't outright hard, but it can be a little tricky if you start getting more and more units. I'm going to show you two of them that are a little more challenging than this, but you're going to have plenty of practice where you're just going to be going through and crushing dimensional analysis problems. Trust me on that because it is super important. So, all right, we're going to do this example. I like this one because it's just kind of interesting and easy to do. So, I'm going to give you the conversion factors, but I want you to think about them for a second. So, how many seconds? In this one, I don't care about rounding, just give me the exact number of seconds. How many seconds are in 7.32 years? Think about all of the conversion factors you're going to need. So pause the video and see if you can write some down. And then I'm going to write down the ones that I would use. So just to start out, we have 1 minute is equal to 60 seconds. I'm not writing it as a fraction just because, I mean, I could, but the PDF online will probably have a fraction, but either way, it doesn't matter. Actually, let me write it as a fraction. Make more sense that way, because I'll just write the arrow. So you have, this arrow is just saying that it can be flipped either way. So you have 1 minute is equivalent to 60 seconds. 1 hour is equivalent to 60 minutes. 1 day is equivalent to 24 hours. And these are all things you know. 1 week is equivalent to 7 days. And then we have 1 year is equivalent to 52 weeks. And this can go back and forth depending on how you have to write it. So what I'm going to do to solve this is we have all of these conversion factors. We need all of these to solve this. So we have 7.32 years. So we have to get rid of years. So where is the one with years? It's right above us right here. So we're going to put 52 weeks on top because we have to get rid of the years. So years is gone. I'm going to cross these out as I go. So now we have to get rid of weeks because we still have to get to a smaller value. So 1 week is equivalent to 7 days. So we have 7 days over 1 week. So weeks is gone and we're now in days. But we still have to get smaller. So what gets rid of days? Hours. So we have 24 hours divided by 1 day. Well, days is gone, but we're still not there yet. We're almost there. So we have to go from get rid of hours. So we have 60 minutes, not the TV show, the conversion factor, divided by 1 hour. Hours is gone. We're in minutes. So we have one more to do. So to get rid of minutes, we have to do times 60 seconds over 1 minute. And then answer is going to be down here because I can't fit it. It's pretty large. And minutes is gone. So we went all the way from years to seconds just by doing some simple algebra. So let's plug all this into the calculator and see what we get. So we have 7.32 times 52. And notice all this on the bottom is 1, so you don't have to divide by anything. That's kind of why I chose this. Times 7 times 24 times 60 times 60. If you do all the work beforehand, you don't have to sit there and keep doing it. As you just plug the numbers into the calculator. So our answer is, I'm going to copy this, because otherwise I am not going to be able to remember. So our answer is 230211072. 1, 2, 3. So we have 1, 2, 3, 1, 2, 3. So you have 230,211,072 seconds in 7.32 years. So you can use this dimensional analysis stuff for literally anything. Like even if you wanted to make like a cheeseburger or something. But I kind of made this example up for you guys since I am not quite sure what everything is with TikTok, but literally all my students use it. So anyways, let's go over some basic things that we need to know. Example. So the speed of light is a constant in the universe. Wow, P. Speed of light is equal to 3.0 times 10 to the 8 meters per second. You're never going to see it written, like there's going to be M over S, but I'm doing it just to make a point. Alright, so here's our word problem. You don't have to copy this if you don't want to. I'm just going to show you that you can use this for whatever you want. So let me write this out and I'll read it. So you send your friend a TikTok video. And you notice that it arrives pretty quickly, almost instantly. On their phone, almost instantly. Alright, so we're going to ignore a few things. So we're going to ignore like atmospheric conditions. We're going to ignore a whole lot of stuff like distance between relay towers and all that crap. We're just going to focus on, or not relay, your cell towers. Same thing. We're going to just focus on the distance of a geosynchronous orbit for most telecommunications satellite, just the height, and the speed of light to kind of approximate this. It's going to be a little off, but it'll be pretty close. So, anyways, ignoring cell phone tower distance from you, cell tower distance and environmental interference, how long does it take your video to reach your friend's phone? And I'm going to make another note. Okay, so you send your friend a TikTok video and notice it arrives on their phone almost instantly, ignoring cell tower distance and environmental interference. How long does it take your video to reach your friend's phone? So we have to also set up that satellites orbit at approximately 37,000 kilometers above Earth. Okay, so I'm going to give you a second to copy all this down, and then we're going to go to the next page and solve this. So, also, one more thing. Note. Your signal travels to and from the satellite. So that's important. Okay, so let's set this up. First thing we have is 37,000 kilometers. And remember, it travels to and from, so that's going to be times 2. So that's going to actually be 74,000 kilometers total distance. Right. So, and then the speed of light is, it's c, but c equals 3.0 times 8m over s. Okay, so first, if you notice, this is in meters, this is in kilometers. We have to get one of these to the same unit. So since I already wrote down kilometers, I'm going to just convert this. So if you remember from your SI worksheet that I gave you and your table that I put on Canvas and that I've probably handed out in class, or at least shown you in class, a kilometer contains 1,000 meters. So we're going to multiply this by 1,000 meters over 1 kilometer to cancel this out. And then now we have to get into seconds because we're trying to figure out how many seconds it's going to take for our signal to go to and from the satellite to our friend's phone. So because it's an electromagnetic radiation, or a form of electromagnetic radiation, it travels at the speed of light. So we multiply this by 1 second divided by 3.0 times 10 to the 8. So, and this would be meters. So now we are in seconds. So we're going to plug this in the calculator and see what we get. It's going to be pretty quick, I can tell you that. So we have 74,000 times 1,000 times parentheses 1 divided by 3.0. And then this EE button here just means times 10 to the power of. So on your calculators, it might just say EE, or you might have to hit second EE. That's exactly what it means. So I'm going to go over that more in class, but just so you know, that's what it means. And then we close the parentheses. And our answer is approximately 0.247 seconds, which is pretty fast. I mean, that's, you can't even really, I mean, you can, but like that's, I mean, you can count to 1, and I mean, that's really, really quick. It's almost instantly. So that's just showing you how you can use dimensional analysis to figure out like literally anything. And I figured it would be kind of an interesting example to go over. But that's it for this video. If you have any questions, please ask in class, or email me or on Canvas, and I'd be more than happy to help you.